Hi, this is Zach Semke with Passive House Accelerator, and thanks for tuning in to this special bonus episode of the Passive House podcast, recorded at Passive House Network's 2023 conference in Denver, Colorado. And a big thank you to EnerSign for the support of the series. The interview you're about to hear was hosted by Ilka Cassidy, co-host of the Passive House podcast.
This is Ilka Cassidy from the Passive House Accelerator podcast, and we are here in Denver at the Passive House Network conference. And I'm here with Chris Magwood.
Yeah, it's really nice to be here with you.
You are going to present here today in a little bit, and can you tell us a little bit more about you, what you do, and then about the session that you're going to present?
Sure, yeah. I guess quickly, my background is in the design build world, and specifically the high performance design build world, and then even more specifically in kind of like bringing natural building materials to high performance building. And as part of that work, I've got really interested in the embodied carbon of the materials, like what's the carbon footprint of all this stuff we're using. And so that's kind of what I've been focusing on for the last 5 or 6 years now. At first with Builders for Climate Action, with the beam tool development, and now with Rocky Mountain Institute.
Yeah, it's amazing. I mean, the beam tool is something that everyone knows by now.
Hopefully, yeah. Yeah, I think we just hit 3,000 users, so that feels really good. Yeah. It's
amazing. I definitely want to hear a little bit more about it. But first, can you just talk a little bit about the session that you're going to present?
Sure. Yeah. So I'm one sort of presenter on a panel about embodied carbon. What I'm going to do is present on with Builders for Climate Action and the beam tool. We did a bunch of modeling studies, one for the Canadian government, a couple for 3 different projects for cities in Canada, and then one for a developer in the southeastern United States. So we now have 900 homes that we've run through the beam calculator, and so I'm just going to sort of do the high-level overview of this is what embodied carbon looks like from all the houses that we've studied. Here are the big here's where all the embodied carbon is in these material categories, and here's what you can start to do about it.
Yeah. And how does the beam tool work?
Yeah, so the beam tool, it takes the dimensions of your building, so it makes a model, I guess, similar to an energy model, where you're looking at the area of walls and windows and floors and roofs, and then it associates, it kind of does material quantity takeoffs from those areas, and then associates an embodied carbon factor from an environmental product declaration for a given product with that, so that you can see in the tool in sort of real time. You open it up, and if you're, say, comparing insulation products, you tell what R value you're looking at, and you'll kind of see the embodied carbon of all of these different insulation products or types of concrete or roofing materials or whatever the material happens to be. The idea is you can sort of start to do that direct comparison and do anything from just compare one material to another to sort of model a whole building and see what the carbon footprint of everything is in total.
Yeah, so in a way it just makes quantifiable what our what we kind of think what the best materials are going to be, right? But I'm sure that you're going to run into surprises too, right?
Yeah, there are some surprises. I think a lot of things people probably would intuit. The things that have high embodied carbon are the things that need a lot of fossil fuel energy to make. So if you think about heating up rocks or glass until it melts, if you think about melting ore to make steel, heating up rocks to make concrete, like all of those things do show up. Some of the surprises are sometimes in the petrochemical foams, because they may not have a lot of fossil fuel energy in the production, but there's a lot of greenhouse gases emitted in the actual chemistry of them. Like as they're being made, there's various stages where things off gas, and those chemicals are big greenhouse gas drivers. So it's it's interesting, people, especially when we show builders, when they start scrolling through the tool, there's often some, good moments of realization, like, oh, I had no idea that one was either high or low, or,
Yeah, this is actually something that I'm very curious about in this conference, to find out what everyone uses their tools for, maybe besides of what it's actually meant to be or be made for.
Yeah.
So do you see any different usage of your tool that helps people convey, the issue of embodied carbon?
Yeah, I think I didn't think about how much it would get used just in straight material comparisons. We built it to do whole building models, and specifically low-rise residential models, because that was kind of the gap in the market and what my background is in. So I was looking for a tool to do those things. But I am hearing from a lot of architects who do much larger projects who just like it because it is a fast comparative tool, so they can sketch out studies of wall systems, flooring, roofing, those sorts of things really quickly, and before they've gotten into actual design on a larger project. So that's definitely a use that I didn't predict for the tool that people are really seem to be using it for.
Yeah, that's great. So how did you, I know it's hard to collect all the data to use in the modeling tool, right? How did you go about that?
Well, quite literally, the first version of Beam was just me scouring every website where I thought I might find an environmental product declaration and sort of downloading it and then taking the information and putting it into a spreadsheet. And to be honest, that's still kind of how Beam goes. The folks at Building Transparency are working, well, they have a really large database now of EPDs that they have a free API that you can sort of connect to. So at some point soon, we'll stop doing the data collection part ourselves, and we'll start working with one of the other tools where that's their focus is to maintain.
Yeah, it's important as there are more and more tools coming out like that you can actually use the same database.
Yeah,
correct?
exactly.
Otherwise, you can't really compare your results at all.
Yeah. It would have been nice to do that from the get-go with Beam, but the reason that we made Beam is that at the time, things like the EC3 tool and Tally and OneClick, they were really built for the sort of larger buildings world, and they literally didn't have the materials that me as a low-rise residential builder wanted. And so I could have connected with them, but I wouldn't have got the materials from them that I needed. But that's, they're all growing to include more and more types of materials, and so at some point soon it'll make sense to combine and all be using the same data. Yeah.
And there's something that seems like I keep hearing more and more about as well. It's just looking at recyclability of materials, kind of the circular economy. Is that something that you're looking into as well, and something that you might be able to incorporate into your Beam tool?
Possibly. It's tricky because, personally, circularity has been at the heart of what I've been doing my whole career. And I think as a whole, especially in the low-rise world, residential world, thinking about design for disassembly, to me, is one of the most important things we can be thinking about. Which, if you can take all the components of the building apart without wrecking them, then they become much more reusable, recyclable. But in terms of looking at the embodied carbon, when something is recyclable, we're trying to predict what might happen to that material some number of unknown decades into the future. And, a lot of life cycle assessment tools want to put a number to that, but it's a wild guess of a number in terms of, as resources get more scarce, as energy starts costing more, I think we'll treat those materials differently at end of life in a decade or 2 decades or 5 decades. And so I think it's really important today to be thinking about, can I be using materials and using them in a way that helps the most at end of life, but we also can't know what that end of life is going to look like.
Yeah, I mean, one one way to look at that is a term that I've also heard now more and more is the urban mining index. So, which is trying to put a number towards that future mining of that material, correct? So,
and wouldn't it be great if they looked back at us and thought, wow, they made it really easy for us to do that, you know? Yeah. The last project that I did with Endeavor Center was a house that was fully built to be disassembled, and we actually took it apart and put it up and took it apart and put it up a number of times with no waste. And it's like that, you know, that's what the next generation needs us to be doing now, is to make sure that while we are still using fossil fuels, like we do still have this economy of scale where it's relatively cheap to make these things, like to make them in a way that they are usable in the future, and not usable in a, well, I can smash all that drywall apart and put it in a truck and take it somewhere and melt it down and turn it into a new sheet of drywall. But like, oh, if I just take those visible screws out of that sheet of drywall, I have a useful sheet of drywall that can go somewhere else. I think, you know, even more than recyclability, that kind of reusability is really, you know, we should be thinking about that a lot right now.
Yeah, and it really informs your choices of assemblies too, right? Which material you're using for something that is, for example, liquid applied or taped or you know, spray foam. For example, I mean, whatever.
The things that are really hard to ever get apart again.
So when you start thinking about airtightness, you might want to start thinking about, how do I get this building airtight without using materials that basically ruin the reusability of the material. You know, I think it's a really, really interesting topic. So what's next?
What's next? Well, I'm working with the ResNet organization to make a standard for measuring embodied carbon in homes that will kind of align the life cycle assessment world with the way energy modelers do their modeling. You know, it's whether you're modeling a building for Passive House or for a HERS rating or in Canada with HOT 2000, you're making this model that you could very easily be also looking at embodied carbon from the information you've already input. So we're trying to make a standard so that you know, there's a way that the tools can be built out so that those analyses happen or could happen at the same time. And
well, and what's interesting about that is once you I mean, it's basically developing a model, right? It's most likely a 3D model in some form or shape that you attach data to. Correct? And then once you have that, there are basically endless opportunities to attach more data to it. For example, the circularity or that urban mining index.
That's right.
So I think that's really, really interesting too. And then you can start mapping out, even on city levels, buildings that have been built and put into this kind of modeling tool for future use.
Yeah, and I think having some shared sort of like underlying standards for making those models is important, because what I fear happening with embodied carbon is what's happened with energy efficiency, which is that you have all of these different systems of measuring, and they all do their thing and they're all for a certain purpose, but you can't, like, they don't compare and talk to each other. And so what I would love is if Passive House wants to do embodied carbon, let's do it the same way that ResNet is doing it, that it's being done in Canada. And like what you then do with those numbers is up to you. But if we can measure it the same way, then you know, a Passive House modeler looking at their embodied carbon results can turn to some other modeler looking at their embodied carbon results, and at least the embodied carbon side, they're comparable.
No, I think that's really important for comparability too. But I also feel like you can't really dictate one specific software that everyone needs to use, right? So I think it's good to think in a way where everyone can use whatever they have been using, because it's not easy to switch over. But make it comparable.
Yeah.
Yeah, I think that's,
Yeah.
that's a really good
Yeah.
way of thinking. Great.
Yeah.
Thank you so much.
Yeah, it's always a pleasure to talk to you.
Yeah, I'm looking forward to your session.
Thanks.